Data analysis. What is the wealth of our country? Who's got it? How is it changing? What are the consequences of an experimental drug? Does it work or does it not? Or does its effect depend on conditions? What is the direction of the stock market? Is there a pattern? What is the historical trend of the world climate? Is there evidence of global warming? This is a diverse lot of questions with a common element. The answers depend in part on data. Human beings ask lots of questions, and sometimes, particularly in the sciences, facts help. Data analysis is a body of methods that help to describe facts, detect patterns, develop explanations, and test hypotheses. It is used in all of the sciences. It is used in business, in administration, and in policy. The numerical results provided by a data analysis are usually simple. It finds the number that describes a typical value, and it finds differences among numbers. Data analysis finds averages, like the average income or the average temperature, and it finds differences like the difference in income from group to group or the differences in average temperature from year to year. Fundamentally, the numerical answers provided by data analysis are that simple. But data analysis is not about numbers. It uses them. Data analysis is about the world, always asking, how does it work? And that's where data analysis gets tricky. What is data analysis? Analysis of data is a process of inspecting, cleaning, transforming, and modeling data with the goal of discovering useful information, suggesting conclusions, and supporting decision making. Data analysis has multiple facts and approaches, encompassing diverse techniques under a variety of names in different business, science, and social science domains. Data mining is a particular data analysis technique that focuses on modeling and knowledge discovery for predictive rather than purely descriptive purposes. Business intelligence covers data analysis that relies heavily on aggregation, focusing on business information. In statistical applications, some people divide data analysis into descriptive statistics, exploratory data analysis, and confirmatory data analysis. EDA focuses on discovering new features in the data, and CDA on confirming or falsifying existing hypotheses. Predictive analytics focuses on application of statistical or structural models for predictive forecasting or classification, while text analytics applies statistical, linguistic, and structural techniques to extract and classify information from textual sources, a species of unstructured data. All are varieties of data analysis. Data integration is a precursor to data analysis, and data analysis is closely linked to data visualization and data dissemination. The term data analysis is sometimes used as a synonym for data modeling. Types of data analysis. 6 types of analysis every data scientist should know. Descriptive, exploratory, inferential, predictive, causal, mechanistic. Descriptive, least amount of effort. The discipline of quantitatively describing the main feature of the collection of data. In essence, it describes a set of data. Typically, the first kind of data analysis performed on a data set, commonly applied to large volumes of data such as census data. The description and interpretation processes are different steps. Univariate and bivariate are 2 types of statistical descriptive analysis. Types of data set applied to census data set, a whole population. Example, census data. Exploratory, an approach to analyzing data sets to find previously unknown relations. Exploratory models are good for discovering new connections. They are also useful for defining future studies or questions. Exploratory analyses are usually not the definitive answer to the question at hand, but only the start. Exploratory analysis alone should not be used for generalizing and or predicting. Remember, Correlation does not imply causation. Type of data set applied to census and convenience sample data set, typically non-uniform. A random sample with many variables measured. Example, microarray data analysis. Inferential aims to test theories about the nature of the world in general or some part of it based on samples of subjects taken from the world or some part of it. That is, use a relatively small sample of data to say something about a bigger population. Inference is commonly the goal of statistical models. Inference involves estimating both the quantity you care about and your uncertainty about your estimate. Inference depends heavily on both the population and the sampling scheme. Type of data set applied to observational, cross-sectional time study and retrospective data set, the right randomly sampled population. Example, inferential analysis. Predictive, the various types of methods that analyze current and historical facts to make predictions about future events. In essence, to use the data on some objects to predict values for another object. The models predicts, but it does not mean that the independent variables cause. Accurate prediction depends heavily on measuring the right variables. Although there are better and worse prediction models, more data and a simple model works really well. Prediction is very hard, especially about the future references. Type of data set applied to prediction study data set, a training and test data set from the same population. Example, predictive analysis. Causal, to find out what happens to one variable when you change another. Implementation usually requires randomized studies. There are approaches to inferring causation in non-randomized studies. Causal models are said to be the gold standard for data analysis. Type of data set applied to randomized trial data set, data from a randomized study. Example, causal analysis. Mechanistic, most amount of effort. Understand the exact changes in variables that lead to changes in other variables for individual objects. Incredibly hard to infer except in simple situations, usually modeled by a deterministic set of equations, physical or engineering science. Generally, the random component of the data is measured error. If the equations are known but the parameters are not, they may be inferred with data analysis. Type of data set applied to randomized trial data set, data about all components of the system. Example, mechanistic analysis. Quantitative and qualitative data analysis. Analyzing information involves examining it in ways that reveal the relationships, patterns, trends, etc. that can be found within it. That may mean subjecting it to statistical operations that can tell you not only what kinds of relationships seem to exist among variables, but also to what level you can trust the answers you're getting. It may mean comparing your information to that from other groups, a control or comparison group, statewide figures, etc., to help draw some conclusions from the data. The point in terms of your evaluation is to get an accurate assessment in order to better understand your work and its effects on those you are concerned with, or in order to better understand the overall situation. There are two kinds of data you are apt to be working with, although not all evaluations will necessarily include both. Quantitative data refer to the information that is collected as or can be translated into numbers which can then be displayed and analyzed mathematically. Qualitative data are collected as descriptions, anecdotes, opinions, codes, interpretations, etc., and are generally either not able to be reduced to numbers or are considered more valuable or informative if left as narratives. As you might expect, quantitative and qualitative information needs to be analyzed differently. Quantitative data, the frequency, rate, duration of specific behaviors or conditions, test scores, example, scores or levels of knowledge, skill, etc. Survey results, example, reported behavior or outcomes to environmental conditions, ratings of satisfaction, stress, etc. Numbers or percentages of people with certain characteristics in a population, diagnosed with diabetes, unemployed, Spanish speaking, under age 14, grade of school completed, etc. Data can also be collected in forms other than numbers and turned into quantitative data for analysis. Researchers can count the number of times an event is documented in interviews or records, for instance, or assign numbers to the levels of intensity of an observed event or behavior. For instance, community initiatives often want to document the amount and intensity of environmental changes they bring about, the new programs and policies that result from their efforts. Whether or not this kind of translation is necessary or useful depends on the nature of what you are observing and on the kinds of questions your evaluation is meant to answer. Quantitative data is usually subjected to statistical procedures, such as calculating the mean or average number of times an event or behavior occurs, per day, month, year. These operations, because numbers are hard data and not interpretation, can give definitive or nearly definitive answers to different questions. Various kinds of quantitative analysis can indicate changes in a dependent variable related to frequency, duration, timing, when particular things happen, intensity, level, etc. They can allow you to compare those changes to one another, to changes in another variable, or to changes in another population. They might be able to tell you at a particular degree of reliability whether those changes are likely to have been caused by your intervention or program, or by another factor known or unknown. And they can identify relationships among different variables which may or may not mean that one causes another. Qualitative data. Unlike numbers or hard data, qualitative information tends to be soft, meaning it can't always be reduced to something definite. That is in some ways a weakness, but it's also strength. A number may tell you how well a student did on a test. The look on her face after seeing her grade, however, may tell you even more about the effect of that result on her. That look can't be translated to a number, nor can a teacher's knowledge of that student's history, progress, and experience, all of which go into the teacher's interpretation of that look. And that interpretation may be far more valuable in helping that student succeed than knowing her grade or numerical score on the test. As explained above, qualitative data can sometimes be changed into numbers, usually by counting the number of times specific things occur in the course of observations or interviews, or by assigning numbers or ratings to dimensions. Example, importance, satisfaction, ease of use. What is the importance of data analysis? Data analysis is important to businesses will be an understatement. In fact, no business can survive without analyzing available data. Visualize the following situations. A pharma company is performing trials on number of patients to test its new drug to fight cancer. The number of patients under the trial is well over 500. A company wants to launch new variant of its existing line of fruit juice. It wants to carry out the survey analysis and arrive at some meaningful conclusion. Sales director of a company knows that there is something wrong with one of its successful products, however, has not yet carried out any market research data analysis. How and what does he conclude? These situations are indicative enough to conclude that data analysis is the lifeline of any business. Whether one wants to arrive at some marketing decisions or fine-tune new product launch strategy, data analysis is the key to all the problems. What is the importance of data analysis? Instead, one should say what is not important about data analysis. Merely analyzing data isn't sufficient from the point of view of making a decision. How does one interpret from the analyzed data is more important. Thus, data analysis is not a decision-making system, but decision-supporting system. Data analysis can offer the following benefits: structuring the findings from survey research or other means of data collection, break a macro picture into a micro one, acquiring meaningful insights from the data set, basing critical decisions from the findings, ruling out human bias through proper statistical treatment. Things to remember while doing data analysis. The focus groups are done. The questionnaire data is in. The interview data is in. The creative evaluation data is in. Now you have a mountain of information before you. Now comes the part when you get to see what stories the data tells you through your data analysis. Your data tells you whether you have achieved your outcomes or not. It's like a big equation. If the outputs and indicators related to a specific outcome mostly or all say positive things, then you can be reasonably sure you have achieved that outcome. If they mostly say negative things, then you can be reasonably sure you haven't achieved that outcome. Like with other parts of doing a program evaluation, there are different ways to analyze data. This is important because how you analyze it will affect what kind of conclusions and recommendations you come up with. Here are some key things to keep in mind. Different people will tend to see different things in the data. Therefore, the more people you can involve in the data analysis, the more complete of a picture you are likely to get. Quantitative data analysis. This involves adding up the numbers. For example, the total number of educational workshops given, the total number of hits to the website, etc., and comparing it to the outputs, what was planned. Calculate your mean, the average of a group of numbers, and your median, the middle point of a group of numbers, where 50% of the numbers fall above the median and 50% fall below, where appropriate. Qualitative data analysis is a bit more tricky. It involves looking for patterns, trends, themes. Data analysis can be inductive, which means you use the data to generate ideas. You don't go in with a predetermined thing you're looking for. You keep your mind open as much as possible and let the data speak to you. Data analysis can be deductive, which means you analyze the data looking for something predetermined. For example, you look at the data to see which of the literacy programs you surveyed had more impact. When you're looking at your data, you can analyze for merit, which means effectiveness. If something works locally, specifically in the context you are evaluating, it's a specific perspective. When you're analyzing your data, you can also look for worth, which means whether the program has value to greater society. It's a broader perspective. Watch for triangulating your data, which simply means cross-checking your data. Here's an example. Let's say you asked program participants about how useful the literacy training program was for them, and you also asked the same question of the program staff. You can triangulate or cross-check your data by comparing what each group's responses are. If the participants say it was terrible and the program staff says it was great, you know you have an issue. If they both say the same thing, you can be more confident in what the data is telling you. Look for reliability, which doesn't mean whether your friend does what she or he says she or he is going to, but rather in the case of evaluation means can the data be trusted? Is it right? Correct. Look for validity, which means does the data measure what it sets out to measure? For example, if you ask a question that is vague or confusing, the responses may not be valid. That is, they may not measure what you set out to measure. This seems self-evident, but you would be surprised how often people forget to do this. The main benefits of data analysis are rather self-evident. How can someone improve their processes and identify problematic issues if they are not willing to look at the data? The answer, of course, is that they cannot make reliable improvements without data analysis. The keyword here is reliable. Most people have a general idea about possible changes that should or could improve their processes. However, when it comes to these sorts of changes, there is the inherent risk that the changes does not have the desired result. There can also be unexpected consequences that impact some other aspect of that organization in a negative manner.